Hi. Say hi, everybody. Hi. Hi. All right. We're gonna make another video. I'm recording right now. This is for all the people on the nice Spanish field trip while we're inside. Say hello. All right. So first thing is on Classroom, I did with a lot of hard work, and it's I was hoping I could make it private channel, but I can't. So this is public. But I don't think there's a lot of people that are going to watch my video. But anyway, I had to put it on YouTube. I'm like, because like I was just, when I was making the video, I'm like joking around and I'm like laughing. And it was an unedited version. So it doesn't matter. I know, right? Um, so, so the video that I've currently posted is 13.2. It's comparing population proportions. You got to watch that one because it's a different twist to it. Um, and then today I'm going to quickly do the second Frappy in that packet. Now, what I would suggest is stapling all the orange together, and I should have done that, but I didn't. Do you guys want to get the staplers and do that? There's one in the back, and then there's one on my desk. No, all the orange, like, no. Yes, I do. Yeah, but I'm not there yet. So then I also put up due dates. So um, these were suggested due dates. There's suggested ones and then mandatory ones at the bottom. The only thing that you guys have to be, but the only thing that you have to hand in before the break is that yellow packet, the 53 multiple choice questions and corrected. If not, if you don't hand it back in, then I'm just going to use the grade that you got. I'm just giving you a second opportunity to get a better grade out of the 53. Okay? All right. So yeah, so we're going to finish chi-square goodness of fit test today and then look at test of association today. Then you'll be watching, I'm making another video on to finish chi-square. And then tomorrow and the 2 days before break, we're going to finish the course. And then there will be one more video. So if you can't watch the videos until after break, I mean during break, that's fine. There's no rush. You have plenty of time to watch the videos and like read the chapters and really like dive in. But if you have the extra time and you want to just get bonus points, then do it. If not, and you want to really just sit down and read the chapters and grasp the material, then wait until the first, second, and third. Oh, that should have been orange. Oh, wait, why? I mean, how come the yellow is not coming up? That's weird. I made all these yellow. All right, for chapter 15, I'll see if I can fix that. All right, so let's go back to the packet that we were in yesterday, which was the goodness of fit. And we're going to do test of association today, too, because that's easy. Yeah, we have to finish this one, okay? So just to recap, chapter 14, again, all these chapters that I'm going through relatively quickly, I'd like you to read the chapters, okay? The textbook is it's not that bad of a read, in my opinion. Some chapters are better than others. But chi-square has 3 tests: goodness of fit, test of association, and homogeneity of populations. We're finishing goodness of fit and doing association today. So now, these are just some notes that I have just to recap what we did yesterday. Chi-square, this little fancy x squared highlights the distribution itself. But the chi-square test statistic is more like where is that? Where's the test statistic? Is more a capital X squared. So the distribution, when they're talking about the distribution, it's a fancy X, but the chi-square test statistic is just a regular X. That's one thing. We said yesterday that the goodness of fit test is basically saying I have this population that should adhere to these proportions. We're trying to see if it's different. Now, from a like biology standpoint, usually you want to fail to reject the claim because you want your populations to be adhering to what they should be. But like that's why I feel like that's a little different. The other ones we'll see, but this one I feel like you want to fail to reject. So now the conditions are really easy. All expected counts are at least 5. And we kind of got into, I'm recording right now. It's up in the testing center. Okay. Yeah. We kind of got into this, but the bell rang. So remember I put up the picture from yesterday? I'll do that. So do you guys still have that data in your calculator? Yeah. So test, goodness of fit test. You remember we had to put it in list 1, list 2? Right, guys? Yeah. So the observed is list 1, expected list 2. Degrees of freedom was how many proportions you have minus 1. So that would be 4 minus 1 is 3. And so I told you to draw it so you can see. The chi-square distribution for small samples is skewed right. It's never going to go into the negative because it's squared. So it's skewed right for small samples, but then as n increases, you can see degrees of freedom 4, it straightens out, degrees of freedom of 8, it gets even more looking like a normal curve, and as you increase your degrees of freedom, you do get to a, yeah, approximately normal, yeah. So, just like the t-distribution, there's different curves for each degrees of freedom. And yeah, we went over this. That's in our cheat sheet folders. Okay, so this is, look what I did. I'm pretty savvy, right? I took a picture over there, and then I emailed it. Now, this is what was on the board from yesterday. That's pretty cool, no? That's skills. Yeah, I know, but I wanted to put it on this because because it's the video. Yeah, because like they won't be able to see me if I refer to that. I thought that was pretty clever. Yeah. And then there's the other part. So we're pretty much picking up where we left off. Just a little recap. So I'm here. So my p-value, you guys are going to want to write this down on your papers now. So we have the chi-square test statistic, which is 6.1867, and the p-value is 0.1029. So write that down on your, you can even sketch the curve if you'd like and show the area of interest right here. God bless you. We picked an alpha level of 0.05, so what does that mean then? We're going to fail to reject the null. And we're going to say that these these observed counts are not that far off from the expected. Therefore, we have no reason to believe that what actually happened is different from what is supposed to happen. Yes. Oh, I didn't go there yet, but I will. Okay. So you guys just tell me. So what does this chi-square test statistic come out to? Because you wrote it down, right? 6.1867. Okay, and then what was the p-value? 0.1029, right? Okay. All right, so let me just show you this now. If you go to stat and then test and then rerun it but not look at the curve and look at the calculations, I want to show you what they do. So calculate. All right, now these we already saw when we drew it, but what these are, if you look at the first component of calculating the chi-square test statistic, so like what I mean is this guy right here, the 99 minus 112.5 squared over this, that would be equal to, what does that come out to be, that one? 1.62? What does this one come out to? Can you see it? Because it's hard for me to go. 0.54, you see? So this one would come out to be, now you're with me? Do you have it on your calculators? Okay, so 0.54. What's this one? 3.5267. And then what's this one? 0.5. Okay, so now these are called components. These are the components that make up the chi-square test statistic. So this one would be labeled as the largest component. So that's the largest component because this one has the biggest difference between what was observed to happen and what was expected to happen and what actually did happen. So say, like, I guess with genetics, this is important, right? Because if they're trying to see, well, where in the population did it go wrong, they can kind of like center in on which component, right? I mean, go for it.
But like sometimes there's something that's on one chromosome.
Right.
So it's like if it's on, I think it's like the X chromosome, it means that the mother has like the trait or something. It always passes down to a son or something like that. I forget how it works.
Right, but I'm sure they look at, like when they're doing these chi-square distributions, they are looking at which component is off the most and then try to, I mean, I would
There
give,
might be a reason, like a wildly off thing.
right,
And like that something like this would just work out.
yes.
What is the CNTR?
I don't know what that actually center, I don't know what that stands for, but that's what it is. No, I mean, if you write out, like if you write out the chi-square test statistic like this, like how we have it written on this slide here, it's fine. Like you don't have to put 1.62, 0.54, like you don't have to put those. By name, you probably would want to write that down then. Yeah. Yeah. So, yes, go ahead.
Oh, so these packets we hand them, those are like our grades basically, and then you like kind of like.
Yeah. Yeah. The packets are counting as grades. Yes, that's what Alex just asked. Yeah. I mean, and as long as they're completed, and I want you guys to actually, if you don't understand something, all this stuff can be looked up. Look it up. Because I'm not able to spend as much time as I can with these last three units. So look them up, learn from them, and ask me questions. Leading up to the AP test, I like pretty much say I'm free for all my AP stats kids, like as much as you need me. So, and Alex asked about having a practice AP over the break.
Oh, I just asked if like you could give us some extra.
Yeah, like I no, not mandatory stuff. No. What I'm going to do is I'm going to give it to you. So like as we start reviewing, we're going to do in-class review, but then you can review as much as you want at home. So I'm going to give you the test that I can physically hand to you. There's questions that are secure that I can't, that I have to keep them in my classroom, but the other ones I'm going to give to you. So I'm going to give you that set, Alex, as optional. You don't have to. All right. So interpretation here is basically we're done with this. So we would, since our p-value is greater than our alpha, our findings are not statistically significant we fail to reject the null and conclude what? What was the point of this? Yeah, that they're not different, right? Because you're failing. But in context, instead of doing it like that, we could just say that the actual population proportion is not different from the hypothesized. Or you could say that the observed population proportions are not different than what was expected, which might be a little easier to write, I think, and conclude that the observed population proportions are not different from the observed. From the expected. All right, so that takes care of this one. Now, I just remembered that I forgot to print out the cheat sheet. Sorry. I'll do that tomorrow for you. Because now we're going to do test of association, which comes up more. Well, goodness of fit and test of association are the major ones. The one that you're going to watch the video on doesn't happen as much. So I'm just going to go to the back of the classroom to get it. I'll be right back.
Oh, there's another pack?
Yeah, there's 5. 4. Oh, and hold on. Can I go back? Yeah. Right, did everybody get one? Wait, aren't there only 4 for the orange? Yeah. Let me just say that. There's 4 packets for the orange, and then there's 5 for the green. Do you guys have the chi-square homogeneity of populations out? Chi-square homogeneity of populations. Do you see that? Has the chart in front. That one. I'm gonna eliminate one of the questions on there. So the first one you're gonna watch the video we'll do together. The second one is optional. So write optional on that. You don't have to do it. Yeah, how are schools doing? Yeah, that one's optional.
And there's another one in the
And then the back one I want you to do.
Okay.
So no. In the homogeneity of populations, the second one that says how schools are doing, that's optional. The third one I want you to do. So I'm just kind of cutting down the work. I actually did make these packets a little smaller. All right, so let's dive into test of association. So the test of association is you're basically given a two-way table. So that's another indication. Like, because now it comes down to the idea of, like, there's 3 chi-square tests, and you're like, okay, well, which one do I use? So goodness of fit is one population. So that's like a hint. Test of association, they usually use association in the wording, and it's a two-way table. So you know it's a test of association. Homogeneity of populations, we'll watch the video on that one, but that is the least common. You notice I couldn't even find questions on it, so I had to pull from the textbook. So the fact that one probably won't even be on it. It's either going to be goodness of fit or test of association. So let's just read this question, and then this is test of association. All right, so it says the Colorado Rocky Mountain Rescue Service wishes to study the behavior of lost hikers. If more were known about the direction in which lost hikers tend to walk, then more effective search strategies could be devised. 200 hikers selected at random from those applying for hiking permits are asked whether they would head uphill, downhill, or remain in the same place if they became lost while hiking. Each hiker in the sample was also classified according to whether he or she was an experienced or novice hiker. The resulting data is summarized in the following table. Okay, so do you guys know anything about hiking? So if you are lost, yeah, that's what I thought. You're supposed to remain in the same place, right?
No, but like, if you know the area really well, you know there's like mountains and stuff, even then, it really depends on the area then.
Yeah, because usually you're supposed to, I think, stay in the same place. So,
So very rarely notice if you're lost.
really?
Well, it depends on the trail, but most trails, if they don't have markers, you could walk for miles and not realize you're lost.
Yeah, I don't know, that scares me. So, I don't do much hiking, but do you think though, like, so what this two-way table is saying, if you're a novice or experienced, do you think that it would be independent upon their direction, or do you think, like, what do you guys think? I feel like if you're experienced, then you probably would know what to do, right? I know. So, I mean, this might show something otherwise, but I would say that they are dependent, not independent.
There's more novice responses than there are experienced.
That is true. There is. Yes. But hold on, but did you get that though? Like, so basically you're looking at a two-way table and you're saying to yourself, would these two categorical variables be unrelated, or would one affect the other, or would they be dependent? And that's what this whole test is. So I love chi-square actually. I feel like the conditions are so much nicer. It's easier to calculate. There's not as much writing. Alex, go ahead. Wait, can you not talk to me about this right now? Because I'm on. Okay. Yeah. All right. So we still have the null and the alternative. Now look at the question. Do these data provide convincing evidence of an association? So there's like in the question itself is using the word association, so you know which chi-square test it is. They also use independent. So they might say, do these data provide convincing evidence of an independence or a dependence, however they word it, between the level of hiking expertise, or they would say, is the level of hiking expertise and the direction independent of each other? Show statistical evidence. So the null then, and I would have had this on the cheat sheet, is there is no association between the two categorical variables. So let's write that. Oops. What? It is. Except that's like goodness if it is population proportions, and it's one population. Here you're dealing with two different populations, and it's categorical data. Chi-squares counts. It's so you're dealing with categorical data. So there is no association between what? The level of hiking expertise and the direction. The direction, the hiker, the direction of the hiker. Let's write that. The other way you could say it, and write this down too. Level of hiking expertise and the direction of the hiker are independent. So that's the null. Always that everything's equal. The alternative, then what do you think the alternative would say? Yeah, there is an association. So there is an association. And then you guys can write on your papers too. ... Because we just repeat that. And then how would, the one that I wrote in red, how would I write that for the HA here? Yeah, level of hiking expertise. Oh, I guess I have to write this one whole out. And the direction of the hiker. No, there's not 3 HAs. Hold on. Are dependent. No. Oh, my bad. Sorry. Okay. The blue is one way to say it. The red is another way to say it.
Wait,
Yes. What is wrong? Oh. Oh. Sorry.
The blue, bottom blue is HA, right?
Oh yeah, what am I doing, guys? All right, let's make this clear. Sorry. See? Unedited version. Okay. Null. Another way to say the null. Alternative for the blue. Alternative for the red. Better? Okay, okay, I'm sorry. Yes. Pick one. Yeah. A lot of times they'll either use the word association or independence. Or dependence, whichever one. All right, so now chi-square is much easier, the conditions. So remember in the one we just did with the fruit flies, we had observed counts and expected counts. So this would be considered what? Observed or expected? Observed, right. This is what they actually said they would do. So this table is the observed counts. You have to come up with the expected counts. And that's a little bit more creative, but I feel like it's common sense. So this is going to annoy me now because I'm going to lose this. Okay, because I need to see this in front of me. All right, so we're basically going to replicate that table and make it expected counts. Well, it depends on the proportion of, like you basically make it expected based on the proportion of how many are novice and how many are experienced. Like you figure out that percentage of the population. You'll see in a minute. Hold on. So let me just recreate this. So novice. Yes, because when you do the expected cell counts, you're in chi-square. All have to be greater than 1, and no more than 20% can be less than 5. So novice and experienced. And then you have uphill, downhill, and remain. Okay. All right, so we got to figure out our totals here. So what are our totals here? Actually, I'll do it over here, up here. So we have 20, 50, 50, what is that? 120. And then we have 40, that's 80, right? So for 200. And then over here we have 30, 80, 90. Okay, so basically the way you come up with these expected cell counts is first you figure out how many novice people you have. So do you have more novice or do you have more experienced? Novice. So what proportion of novice people do you have? 120 over how many people? Yeah. So you do 120 over 200. That's the proportion of novice, right? And then you times it by how many all went uphill, which would be 30. So basically you're just finding proportions here. I'm going to need help with these numbers. Can you guys tell me what those numbers are? So I don't have to keep switching back and forth. Like as a decimal. Or not a decimal. Well, maybe. Just it's 18 exactly? Okay, 18. All right. Now, this one would be, what would the, let's actually, yeah, let's do all of the novice. So all of these are 120 out of 200, right? 120 out of 200. But this would be out of how many here? 80? And this would be 90? Okay, and the red numbers are what it actually equals. So can you guys help me with those? 48 and 54? Okay. And then we do the same thing for experience. So I don't know.
It's 18 exactly.
Yeah, I think it's 18 exactly. All right, so now how would you figure out this one? Yeah, 80 out of 200 times 30. And this would be 80 out of 200 times 80. Yep. And this. Go ahead.
Why is downhill always 80 times 120?
Yeah, you're figuring out the proportion of people that were experienced, and then how many people actually went uphill. So you're dividing them proportionately is all you're doing. So if you can give me those numbers in red, or I'll put them in blue. 12, 32, 36. Okay. So now there's a formula that they say to help you with this. It's row total, which would be 120, times column total, which would be 30, over grand total. I always like to think about it this way, though, because I feel like then you understand what you're doing. But it's row total times column total over grand total, and that will give you any of the expected cell counts. All right, so now the conditions. Are all of these at least 5? So conditions are satisfied. That's why I love chi-square. What do you mean? Are all of these numbers at least 5? That's your conditions. So the only conditions for chi-square is that all expected counts are at least 1 and no more than 20% or less than 5. But if you say all expected cell counts are at least 5, that's both conditions right there, like to summarize. So you could just say all expected counts are greater than 5. And then that's done, satisfied. Okay, so now calculator time. So let's go to our tests. So stat, tests, and now let's find the appropriate chi-square test. Now, goodness of fit test is by itself, and that's where you enter them into the list. This is chi-square test, so let's hit enter. Now, you have to make a matrix. Yes. So A and B are matrix. And the first time I actually taught this, I had no idea that all you had to do was put in the observed, and they actually output the expected. So technically, you don't even have to know how to calculate expected because the calculator will output them. But I always explain how to do it. So do you remember how to enter a matrix? Yeah, and then help me with this edit, right? And what is it? A 2 by 3, row by column, right? Second math, no, second x inverse for matrix, and a 2 by 3. We always put the observed first. The calculator will calculate the expected, which I didn't realize when I first did this. That was by accident. So you just plugging them in, plugging away, and 10, and then 30, and then 40. Okay, quit out of here, and then go stat test, and then back to C. Not goodness of fit, but the other one. And now, even though you didn't enter the expected, it will calculate it for you. So first, let's do calculate. Now, write these numbers down. Write these numbers down so you have them. Yeah, so calculation. Yeah, let's write that. All right, calculation. My name or formula. Actually, I probably should have started this, my bad. By name would be chi-square of association. Oops. chi-square test of association. Formula is the chi-square test statistic. Okay. Now the test statistic, there's a lot of these, much more than what we had yesterday. So you can write out the first one, and then plus dot 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 the last one.
Just write what they have in the calculator.
You could, yeah. But if you want, you could write out like the first one would be 20, because that's observed, minus 18. You square that, and that's all over 18. Now the calculator output that we just saw, oh, it didn't show that. It doesn't show each component like the other one did. I thought it would. Okay, and then let's do the last one. Plus dot dot dot. What would be the last one? You guys tell me. 40 minus 40 minus 36 squared over 36. And so my chi-square test statistic is what? 1.50? 1.505. Okay. And my p-value, high. What is it? 4713. All right, so now let's actually, let's just look at this, the curve of this. No. So I'm going to show you what happens. Yeah. Well, that's a high p-value. Yeah. Oh, the matrix, you go to second x inverse for matrix. So what happens is I actually entered, the first time I did this, I entered in the expected. And then there was one time where I forgot to enter it in. And so then I went to second matrix, and then, do you see? Like, I'm like, oh, wait, what's in here? And then I'm like, oh, the calculator does it for me. That's pretty cool, right? So, like, even if, like, I was tutoring last night, actually, for AP Stats, and there was a question that was actually asking for an expected cell count. You have to know how to do it, but it will do it for you. So, we're done. This is it. So what do we say? Now we're on interpretations. I didn't pick an alpha, did I? Let's do it. Yeah, let's do alpha. It really doesn't with this p-value being so large. Yeah. So we would say, and like if you have something like this where the p-value is super big, you could just be like, since the p-value is very large, our findings are not statistically significant. I could write that too if you want. P-value is large. Our findings statistically significant. Okay, we failed to reject the null. And what does this mean in context? I know I always sound like a broken record with inference. We put an alpha level. We did, just now. I don't know where I just did it, but you really didn't need one here because it's so big. So what does it mean in context? There is or there is not? Yeah. There is no association. Now, I would have thought there would have been one. Wouldn't you guys have thought? Yeah, like if you're out hiking and you consider yourself an advanced hiker, I would think that you would know.
If you consider yourself an advanced hiker, maybe you don't think you're going to get lost.
True. True. There was no association between hiking level and direction the hiker would head. It's so funny because you know how I just stumbled over and you guys are like direction. So on the video, there was one part where I was looking for a word and I'm like waiting for you guys to tell me a word. Like, you know what I mean? You weren't here. I'm like, oh darn it, where are you guys when I need you? And the direction the hiker would travel. Yeah. So, what do you think about chi-square? It's easy, right? Don't you feel like this is one of the easier inference tests? Yeah. I mean, well, there is, but the biggest thing, I love how the conditions go down to almost nothing because all you have to do is, yeah, the chart, basically. Yes. Yeah. No, you wouldn't lose credit. So say you didn't actually show the work like I did right here, and then you just put expected counts and then you just copy down, you'd get full credit. Yeah, but you also just want to say like like that the reader knows that you know what the expected cell counts are, that all expected counts are greater than 5. And that takes care of both of them because if they're greater than 5, then no more than 20% are less than 5. So, yeah, that's it. So, wow, we actually finished early this time. That's good, right? Okay, so I gave you 2 more to do of this. So my recommended homework tonight would be to finish this packet. My recommended homework for last night was to finish, yeah, so like if you're keeping up with me. Now I said the multiple choice questions are a little tricky, so try them, and if you want, like when we come back from break, you guys come and find me, and you can, if you have any questions on them, we can go over the ones that are tricky. I have to actually show you, and maybe I could bring it up quickly right now. Let me type this, chi-square table. I wanted to show you, there is a chi-square table just like there's a t-table. We don't use it that much because, oh, all right, well, I don't need that. All right, so you guys are going. But look in your folders and you'll see the chi-square. We only use this a few times for multiple choice questions, so all right guys, maybe staple these packets together and I'll see you guys tomorrow. You can say goodbye to everybody. Bye. We missed you. Bye.
We should have pizza while they were gone.